In this next section, the properties of limits, I actually want you to do all the examples without actually even looking at the problem. So just skip right to example and see if you can find the answer. Pause the video and then come back in a few minutes and see if you can get it. Okay, hopefully if you're listening now, you actually paused it to see. But this says the limit as x approaches 4 of x squared plus the square root of x. Remember that our first strategy for solving these is just to plug it in. So sure enough, I plug it in and I get 4 squared plus the square root of 4 equals 18. That's the answer. If you got that, that means that you intuitively knew this first property of limits. And the property of limits simply says that if you have one function plus another function, you can do their limits independently. You can find the limit of L. The limit of f of x is L. You can find the limit of g of x, which is m. And then you can just add those two limits together. And that's what we did. We did x squared. We did the square root of x. We got the answer. The same is true if the two functions are being subtracted. Again, I think you probably did this right without even thinking about it. You plugged in the 4, you got 16, you got 2, you got an answer of 14, completely intuitive. And this is a great thing to remember when you guys are in college and you're trying to do these problems, that sometimes you're going to look at something and it sounds so complicated, and it really isn't. This property is super easy. It's just saying that if you have the limit of f of x minus g of x, so two functions are being subtracted, and you're taking that limit as x approaches c, you find the limit of f of x, you find the limit of g of x, and you subtract them. So don't always let the fancy wording get to you. Next one. If you have two functions that are being multiplied, you can multiply their limits. So the first time we're going to plug in pi halves. There's nothing to do to it. It's just x. And then we're going to do sine of pi halves. Now, I cannot stress enough, you have to have these memorized. If you're in AP and if you're in honors, make sure you have a working appendix at your side at all times. But sine of pi halves is 1. If you don't have it memorized, have this picture in your head memorized where you know that this is pi and this is 2 pi. And then if you have that picture, you'll say, oh, pi halves is 1. So the answer to this one is pi halves. Okay. Again, a very intuitive property that you really didn't even need a book to tell you. I think you would have figured it out. Now, there is one caveat. If g of x is on the bottom, it can't be equal to 0 because you can never divide by 0. But otherwise, you're just doing it the same way you were before. I'm plugging in a 2, which gives me 4 plus 4 over 2 plus 1, which is 8 over 3. I didn't graph it. I didn't simplify it. I just plugged it in. That always needs to be your first strategy, is to plug it in. Now on this one, you can try and plug it in, negative 1 squared minus 1, but you can see you run into a problem. You can't have it such that m is equal to 0. So when you go to do this and you get 0, now go back to strategy number 2. So I'm going to just go back here on this screen. Remember, strategy number 1, substitute in. Strategy number 2, simplify the equation. Then substitute in. So we're going to do that. That still is a great strategy, even for these kinds of problems. So you see it's going to be equal to 0. Don't forget to rewrite the limit. We always want our notation to be correct. X minus 1 times x plus 1. You're going to get great at factoring this year if you're not already. I cancel. So this is really just the limit of this function, which is a line. It's a line, has a slope of 1, y-intercept is negative 1. What is this line going to do as x approaches negative 1? So here's negative 1. Where am I? As x approaches negative 1, the y value that I'm approaching from either side is negative 2. Okay, and you can get that just by plugging it in, but I'm going to try and keep showing you the graphs because I want you to be thinking about it. Unless, of course, you get one like the next one where you don't know what the graph looks like. 1 over the absolute value of x. Although I do want you to get better at graphing this later. So let's talk about what it could mean. If I just gave you y is equal to 1 over x, hopefully you recognize that as the parent graph for your basic hyperbolic function. But when you have y is equal to 1 over the absolute value of x, then it doesn't matter if x is positive. It shouldn't change the graph at all. But if x is a negative number, like -2, it's going to make the answer positive. And so this is what this graph looks like. So fortunately, you can figure that graph out because substitution won't work. That was strategy number 1. Strategy number 2 is to simplify algebraically, which you can't do. And then you do have the strategy of making the graph. Now, if you're thinking, I wouldn't have figured that graph out, you have a graphing calculator. If I give you something too unusual, you'll be allowed to use it. So you'd graph it on your graphing calculator, and then you can say that as I'm coming in from the right, so as x approaches 0 from the left, it's going to infinity. And as I come in from the right, as x approaches 0 from the right, it's infinity. And since they match, the answer is infinity. Does it ever actually reach infinity? It can't. Infinity is not a number. It's just a destination. So you can have, as long as both of them are going to infinity, you're good. Okay, so here's another property that would have been completely intuitive if you hadn't even seen this. If I had just given you this example, what would you have done? Strategy number 1, you would have plugged it in. The limit as x approaches pi fourths of pi sine of pi fourths. One that you should have memorized. So pi, and then pi, sine of pi fourths is the square root of 2 over 2. Don't forget that when you're multiplying fractions, you can think of this as a fraction, numerator times numerator, and denominator times denominator. So what is this limit saying? It's saying that you don't have to worry about a constant. So k is just a number. In this case, it's pi, the number 3.14. You can just find the limit, L, and then multiply by k in the end. So we could have just ignored the pi until the very end and it still would have worked. Next one says that if you have a function being raised to a power, just find the limit and then raise that to a power. So again, you would have gotten that just by substituting in. So if you put a 4 in, square root of 4 to the 3 halves, which is 2 to the 3 halves. I would like to talk about different formats for the answer. If you're taking a multiple choice test and you can't recognize different answers, that's going to be a problem. So this is a perfectly valid answer. I'm very happy with it. Another way to think about it is that this is, remember the bottom number means that it's a root of some kind. So it's a square root of 2 cubed. That would be another answer. Not the best answer, but it would be another answer. But then you could simplify that into the square root of 2 times the square root of 2 times the square root of 2. And these two, the square root of 2 times the square root of 2 is 2. So think about that. This answer and this answer mean the exact same thing. And this is one way that on a multiple choice test, your algebra could actually be tested. So even though you're taking calculus and you're trying to learn about limits, algebra will still be a big part of the test because we're going to find out if you can recognize that 2 to the 3 halves means the same thing as 2 square roots of 2. Okay, last section. So this is a special limit that eventually we'll learn more about, but right now I just want you to memorize it. The limit as x approaches 0 of sine of x over x is equal to 1. Remember, first of all, you can't have a 0 in the denominator, so you know that there's not actually an answer. But that's the beauty of a limit. A limit says, what are you approaching from the left and the right? What should the answer be? So this graph actually looks something like this. It approaches 1, and coming from the other direction, it approaches 1. There's a hole there. It's really just a little bit off, isn't it? Really hard to draw. It approaches 1 from both directions. So we can say that the limit is 1, but does it actually have a value there? That's a little better. It does not. So I personally don't actually memorize this in this format. I memorize the picture. I'm much more a visual learner. You might want to add this graph. This is the graph y is equal to sine of x over x, and add that to it. All right, so how are we going to use that? Here's an example of how limits are going to become more complicated. If so far you've been thinking, I don't know, this is pretty easy, then here's some ways that you're going to have to be able to rework these to figure them out. You can't put an x, a 0 in here because you'll get a 0 in the denominator. But happy trig memories here. We're going to rewrite tangent as sine of x over cosine of x, and that x is still there. And now you don't actually have to write this step, but I'm going to write it for everybody so that you can see it. I'm going to change this to sine of x over x times 1 over cosine of x. If this were actually my paper, I would just kind of circle it so I could see it, but I'm pulling it apart so that you can see it. Now remember our properties of limits that we just learned. We learned that you can do limits individually and then multiply their answers. So this limit you just learned is 1. And then for the other limit, 1 over cosine of x, you can plug in 0. Cosine of 0 is 1. Remember that you need to have these memorized, but you not cosine of x, cosine of 0 is 1. And if you don't have them all memorized, then for honors, you should have a chart handy at all times. For AP, you have to have them memorized. But I would just memorize the picture. Here's 0. Here's 2 pi. So cosine of 0 is 1. Having that picture in my head, then when somebody says, what's cosine of pi? I can think, oh, it's halfway. It must be at the -1. So for me, that's easier. Okay, you can multiply two limits together. That's from the properties we just learned, and you get 1. On number 2, we're going to do an interesting thing. You guys are pretty used to having a common denominator. If you have 3 over 4 and you want to add to that 7 over 4, you know that you can call that 10 over 4. What we're not used to doing is unseparating something so that it looks like it has a common denominator. It right now has a single denominator. We're just going to separate it. So this is the limit as x goes to 0 of x over x plus sine of x over x. Last year we did this under the concept of partial fraction decomposition. We're not actually having to decompose anything here. We just are separating them. So now, again, why is this here? Because we just learned those properties. And it's to show you that if you have two limits, so now I'm going to put parentheses around it, so it's the limit of this whole thing. You can do the limit of the first one, which, by the way, that reduces to 1 plus sine of x over x. So this does confuse people. I'm going to do it off to the side here. People get confused. What is the limit of 1 as x approaches 0? Remember that what you're always talking about is an equation y is equal to. This is an equation. Y is equal to this graph. Y is equal to this graph. This is a graph of some kind. Well, y is equal to 1 looks like this. So what is it when x is approaching 0? From either side, it's 1. So the answer to this limit is just 1. And what does this graph look like? We know it looks like up here. It goes up to 1 from both directions. So 1 plus 1 is 2. So it might feel like on these last 3, it went from, oh, I'm kind of getting this, to, wow, now there's a lot to go on. Because we're talking about making sure you really understand that what a limit is, which is the expected y value. So when you see the limit of 1, you have to say to yourself, okay, I'm picturing the graph, y is equal to 1. What is the expected y value as x becomes 0 from either direction? It's 1. And how you can add limits together. All right, I wanted to compare 2 and 3. Very similar situations, but different enough that you need to know the little nuance here. When you're adding, you can separate it into 2 separate fractions. When you're multiplying, they don't all get the x. Only one of them can have the x. If you put an x under all 3, then this would be x cubed, which you don't have. So only one of them can have the x. Well, if you're only going to put it under one of them, let's choose that one, since that's the one that we have this limit for. So again, you have 3 different limits here: 2, sine of x over x, and cosine of x over x. And remember that you can do the limits one at a time. What is the limit? This is the line, y is equal to 2. As x approaches 0 from either side, you're at 2. The graph of sine of x over x is up here, remember? And as you approach 0 from either direction, you're at 1. And what is the limit of cosine of x as x approaches 0? Now, I didn't draw this whole graph, right? But it does keep going and going. As I approach 0 from either the left or the right, it's 1. A limit is the expected y value when you're looking at the graph, which normally you can get just by plugging it in, but I really want you to make the connection with the graph. So the answer is 2. And that's it for limits, except limits going to infinity. So that'll be the next video. Have a great day.